So now let's look at our second example, second formal examples for dividing complex numbers again. And this time, I mean, in this same example, we're probably going to do more than one problem. So part A for that, how about we do 5i minus 4, okay, and over 3i. Okay, so now, first of all, you can notice my numerator fraction right there, it doesn't look to be in the standard form, right? So I prefer to write it as minus 4 plus 5i, okay, and divided by 3i. Okay? And then now, to proceed with the divisions, now what I would need to do always as a rule, you need to look for it in the denominator. In the denominator, you need to look for the complex conjugate of the denominator. So what is the complex conjugate of the denominator? Minus 3i, am I right? Okay, once again, if you're not clear how to find a complex conjugate, go back and review the video lesson that I showed you how to find complex conjugate. Okay, and so here, what else do I need to do with that complex conjugate at the denominator? I need to also multiply this quantity to the top. So I have minus 4 plus 5i, okay, and times minus 3i. So now, my answer here is going to be, at the bottom I have minus 9i squared, right? And on top I have positive, I got 12i, okay, minus 15i squared, okay? And so now, that would give me, on top here, I mean at the bottom, remember I squared equals negative 1, right? And so I squared here at the bottom is negative 1. So together with minus 9, it's become a positive 9. And on top, I have 12i, okay, plus 15. Okay, so on the numerator, I have 12i plus 15. So now to rewrite that in, and I can break that into, so I have 12 over 9i, okay, plus 15 over 9. Okay, and then now at this point here, you can reduce the fraction a little bit, right? 12 over 9, you can reduce it as 4 over 3i, and plus with 5 over 3i. I mean 5 over 3. So now rewriting, I'm not happy with this form of my complex number because it's not in the standard convention, right? So I'm going to rewrite it as 5 over 3 plus 4 third I. That's my final answer. Okay. So let's look at a second example, another problem in this example 2 right here. So we want, once again, we want to divide 1 plus 2i, right, divided by 1 minus i, okay? And so once again, the key step at the bottom, we need to multiply with the complex conjugates, right? You need to multiply with the complex conjugate at the bottom. So 1 plus I, like that. And so you multiply that same 1 plus I quantity to the numerator. So you have 1 plus I on top. And so your answer here is B. At the bottom, you got 1 minus I squared, right? And then on top, it's going to be 1, you FOIL at the top. And then the top here will be 1 plus I plus 2I plus 2I squared. So now the answer would be at the bottom here, after substituting negative 1 for I squared, right? I have 1 plus 1, right? I become 1 plus 1, and on top I have 1 plus I plus 2I minus 2. And so the answer will all turn out to be minus 1, combining like terms and all that, right? Minus 1 plus 3i over 2. And so now, breaking the fractions here apart, then you got minus 1 over 2 plus 3 halves I. And then here, with my final answer here, I cannot reduce, so I'm happy with that, right? So that's where I leave it. Okay? And another example, another problems. Okay? How about we got, this time we got 2 plus 3i, right, divided by 5. Okay? So, once again, you need to find the complex conjugates for the bottom, right? Even though the bottom itself is just simply a number 5, but what is the complex conjugate of 5? And this time here, don't even bother. The point is, the bottom itself is a real number, even though you can regard to that number 5 here as a complex, but always its real nature is a real number, right? So all you have to do is just 2 over 5 plus 3 over 5 I. That's how you're done. You don't even have to bother looking for the complex conjugate. See what I'm saying? It's all because my number 5 right here at the bottom, the denominator here, is a real number. Okay? Besides being a complex, it's also a real number. Okay? So, and that's how I'm done with that particular division problem, right? So let's try another one similar to the first part of the example that we had. So how about this time we do 3 minus 2i divided by 4i. So now here, the denominator here is not a real number. It's a pure complex, right? It's an imaginary component. So we do need to multiply. We do need to look for the complex conjugates at the bottom. We do need to look for complex conjugates at this time. So 4i times minus 4i, the complex conjugate of 4i. Okay? And then I multiply that minus 4i to the top, so I have 3 minus 2i, okay, times minus 4i. So that will give me, maybe we can work it out one more step further on the same line here. I got 16 minus 16i squared at the bottom. But at the top, I am going to have distributive law is going to hold, right? So I have minus 12i plus 8i squared. Okay? So at the bottom, remember, all over, always, I squared is negative 1. I squared is negative 1. So at the bottom here, that becomes positive 16. Okay? And on top, I have minus 12i, right, minus 8. And so breaking the fraction apart a little bit, I can have minus 12 over 16, I, and then minus 8 over 16. So minus 12 over 16, we can reduce that, and to make that minus 3 over 4, I, right? And then the second fraction here is a minus 1/2. Am I right? Because 16 is reduced to 1/2. And then I'm not happy with this form because my I term is in front, so I would like to bring that to the back, right? So what I need to do is turn it into the standard conventions, minus 1/2, minus 3/4 I. And that's how I have just divided my complex numbers.